This video is going to be about adding and subtracting rational expressions. And I just want you to recall that a rational expression is where you have a polynomial divided by a polynomial. So it looks like a fraction, but the numerator and the denominator are both polynomials. And we're going to end up adding and subtracting these. And you're going to use those same methods that you use for adding and subtracting fractions, doing our rational expressions. So these 6 steps are, I just tried to write out something for you to follow in case you do get stuck. The first step is to factor the denominators. Look for that least common denominator. Rewrite your expression with the least common denominator by multiplying by any necessary factors. Add or subtract your numerators, combining like terms. Factor that numerator and simplifying that rational expression if you can divide out any common factors by chance. One of the things you've got to be watchful for is restricted domains. So what I mean by that is what numbers that when you plug it back in would make that denominator 0. So anytime the denominator is 0, you can't have that. You cannot divide by 0. All right. So let's first start by looking at expressions and talking about finding the least common multiple, which will end up being your least common denominator when you add and subtract. So I've got 3 examples here, and I want you to find the least common multiple of those expressions. Let me grab a different color to work with. So for this 2x plus 4, the first step was to factor, and I can take out a 2. And that would give me an x plus 2 when I factor out a 2 from each expression, from each term, I should say. And then this x squared minus x minus 6 will factor into x plus 2 and x minus 3. All right, so now we've got all of these factors, and what I notice is that it has an x plus 2, okay, in common. So my least common multiple has to take into account every factor. So looking that least common multiple, let's see, I have 2, takes care of this guy. I have the x plus 2, and notice I'm only writing it once. It takes care of both of those, and I have an x minus 3. Okay, so the least common multiple is going to be 2 times the quantity, x plus 2 times the quantity, x minus 3. Okay, so taking a look at number 2. Notice I have 3 expressions, and I want to find the least common multiple of these 3 expressions. So if I have x squared plus 3x minus 4, well, I want to factor it. So that's going to factor into x plus 4 and x minus 1. For x squared plus 2x minus 8, that factors into x plus 4 and x minus 2. And then I've got x squared minus 4x plus 4. And that factors into x minus 2 and x minus 2. Well, let's see. That equals x minus 2 quantity squared. All right, so let's take a look at that least common multiple. Again, I said it has to take into account all the factors. All right, so let's see here. We've got this x plus 4. So I'm going to write that down. Notice I only write it one time. Pick a different color here. I have a x minus 1. So I'm going to write that down. And then my last factor, I need a different color than that. We'll go yellow. I've got x minus 2. Now, with that, you're going to want, since it's a multiple, you're going to want that highest degree. So that's x minus 2 quantity squared. There's your least common multiple. Okay. Take a look at number 3. I have 9 times the quantity x plus 2 times the quantity 2x minus 1. So that's one expression. The other expression is 3 times the quantity x plus 2. So here's the great thing, is that these are already written in factored form. So I've got to take a look at this 9 and this 3. The least common multiple would be 9. After that, I have an x plus 2. So that's going to be a factor. And then I have this, I'll go orange, 2x minus 1. So I have included all of the individual factors, which are those least common multiples. Okay, that's how we're going to find the least common multiple of the expressions. Now, we're going to use that skill in order to add and subtract rational expressions. Okay, so directions would look a little like this. We're going to simplify and state any restrictions on your variable. All right, well, let's see. The first step, factor your denominators. All right, so I am going to write the factors below. So that is x minus 1. Over here, the factor is x times x minus 1. All right, everything is factored, all right? So that least common multiple, let me write that. The least common multiple is going to be x, and then you have an x minus 1. All right, so I need to rewrite this addition of our rational expressions with a common denominator. Okay, so we have factored the denominators, we found the least common denominator, and now we're going to rewrite each expression with that least common denominator by multiplying by any necessary factors. Okay, here's what I mean by that. Let me get red here. So in order for this first term, right here, I'll circle it in red, to have this least common denominator, well, I would need to multiply by an x. So I'm going to multiply by an x. So I'm going to have x times x plus 1. Okay? And the reason I multiply the top and the bottom by x, the bottom by x so I get the least common denominator, the top by x because x divided by x is 1. So really I multiplied that first term by 1. Okay, so now let's take a look at this second term. And let me pick, I'll just pick yellow. I'll circle it in yellow. Okay, and I'm looking at this denominator, and it looks like it already has that denominator. So its numerator is -2. I don't have to multiply by anything, okay, because it already has that least common denominator. All right, so after I have rewritten the expression, I'm going to add or subtract the numerators and combine like terms. All right, so the denominator is x times x minus 1. And I have x times x plus 1 plus -2. All right, well, combine like terms. I'm going to go ahead and distribute here and get x squared plus x minus 2 all over x times x minus 1. All right. So with that, I have to, simplified, And I need to now factor the numerator if I can. Okay, notice I said if I can. So let's see here. That is going to factor into x plus 2, x minus 1, all over x minus 1. All right, so now you're going to simplify the expression by dividing out any common factors that they have. They each have an x minus 1. That x minus 1 cancels. This simplifies to x plus 2 over x. Okay, now the directions also say to state the restrictions. So when you state the restrictions, I'll put that over here, restrictions. What you're really looking at is the denominator. The denominator can't be 0. So I'm looking at when does x times x minus 1, which is that least common multiple of the denominator, so that becomes our least common denominator. When does it equal 0? Well, it equals 0 at x equals 0 and x equals 1. So what are the restrictions? X can't be 0, x can't be 1. Those are my restrictions right there. Okay? All right, so that was our first example. We've got many examples. Here's the second one. So I've got x divided by x squared minus 4 plus 1 over x plus 2. So the first thing, I've got to factor the denominator. X squared minus 4 is a difference of squares. That's an x minus 2, x plus 2. And this denominator stays as x plus 2. It's already its own factor. So that least common multiple, the least common denominator for us is going to be x minus 2, x plus 2. Okay, the x minus 2, because it's right here, and the x plus 2 takes care of those two. Okay, so with that, I'm going to rewrite with x minus 2, x plus 2, plus x minus 2, x plus 2. Now I'm going to look at this first term and notice it already has that denominator, so I'm just going to bring that x over. Out of the second term, I have 1 over x plus 2. Well, what does it need? It needs the x minus 2. So I'm going to multiply by x minus 2 on top and bottom because that's like multiplying by 1. So I have plus 1 times x minus 2. All right. I'm going to put it all over the same denominator. So that is x plus 1 times x minus 2. I'm going to simplify. That's x plus x minus 2 over x minus 2, x plus 2. That is x plus x, which is, what, 2x minus 2 over that denominator. I can factor the numerator, and then I'm going to look, does anything on the top simplify with anything on the bottom? Answer is no. That is simplified. That is your simplified rational expression. Well, we've got to look for our restrictions. So our restrictions are going to come from that least common multiple. So what do I know? X can't be what? Let's see. This one gives me 2, so x can't be 2. And this one gives me negative 2. So x can't be negative 2. There are your restrictions. Okay. All right, next example. Number 3, we got 5y plus 2 over xy squared plus 2x minus 4 over 4xy. Okay, so notice on the denominators, we do not need to factor because it's already in factored form. It's one term. So I've got to take each term here. So let's see, I've got the 4. I've got the x. And then I have a y squared and a y. And again, we're taking the highest degree. Okay, so that's going to be a y squared. Right? That is our least common multiple of the denominator, which is our least common denominator. So I need a 4xy squared plus a 4xy squared. So let me grab that red color. I need 4xy squared out of this first term, which means I'm going to be multiplying by 4. And when I multiply by 4 on the top, I'm multiplying the whole thing by 4. Okay? And that would give me my 4x squared on the denominator. All right, so that gives me 4 times 5y plus 2. All right, out of the second expression, I have the 4, I have the x, I have a y, I need y squared. So I have to multiply here by y, and I'm going to multiply the whole thing by y on the numerator. So that gives me y times 2x minus 4. Right? If you'd like to, you could go ahead and do your restrictions once you find your least common multiple. So for here, what makes that 0? Well, let's see. X can't be 0. Y can't be 0. There's my restrictions. So now I'm going to go ahead and solve over here. I have 20y plus, actually, you know what? Let me rewrite this until we get a little bit better at it. Let me rewrite it in steps here. It's all over 4xy squared. So that would be 4 times 5y plus 2 plus y times 2x minus 4. All right, now let's simplify. That's 20y plus 8 plus 2xy minus 4y all over 4xy squared. All right? So let's take a look at what we have here. Common like terms on the top are the 20y and this negative 4y. That gives me 16y plus 8 plus 2xy all over 4xy squared. All right, let's see what we can factor out at the top. What they all three terms have in common is a 2. So that is 8y plus 4 plus xy. And that's all over 4xy squared. Now, anything on the top, simplify with the bottom. This 2 goes in here once and in here 2 times. That simplifies to 8y plus 4 plus xy all over 2xy squared. And that is your simplified expression. Okay. All right, next example. I got negative 5y over 2y minus 1 minus. So now we're going to subtract here. So you'll need to watch for an additional step. Minus y plus 3 over 2y minus 1. Well, what is that least common multiple? We'll see. I have this 2y minus 1, and I have a 2y minus 1. Well, guess what? It's 2y minus 1. Okay. So with that, I can rewrite this all over 2y minus 1. And what would those restrictions be? Well, when does 2y minus 1 equal 0? Well, 2y is 1. Divide by 2. Y is a half. That means restriction, y can't be a half. That's my restriction. Okay. Well, let's go ahead and simplify here. I got negative 5y minus, now when you're subtracting that entire quantity. You need to distribute the negative. Negative 5y minus 3 all over 2y minus 1. All right, let's see here. That's a negative 6y minus 3 over 2y minus 1. All right, let's see what we can simplify out of the top. Take out a negative 3, and that gives me 2y plus 1 over 2y minus 1. Well, nothing cancels. Nothing simplifies, so that is my simplified rational expression. Okay. All right, next example. I've got x plus 3 over x minus 2 minus that 6x minus 7 over x squared minus 3x plus 2. All right, well, we need to find that least common multiple so we can have a least common denominator. I've got this x minus 2. That's already a linear term. X squared minus 3x plus 2 will factor into x minus 2 and x minus 1. All right, least common multiple. Let's see here. I've got an x minus 2. And then I've got this x minus 1. So that is my least common denominator. Well, what are the restrictions? Restrictions, x can't be 2, x can't be 1. Those are my restrictions. Okay. All right, so let's get this simplified expression here. I got x minus 2, x minus 1, x minus 2, x minus 1. All right, let me grab that red. All right, out of this first term, I have the x minus 2. I need to multiply by the x minus 1. So I'm going to take this x plus 3 and multiply by x minus 1. So I have x plus 3 times x minus 1 minus. Let's see, out of this second term, I already have that denominator, so I can just leave that as 6x minus 7. I'm going to rewrite it all over that same denominator. So I have x plus 3, x minus 1, minus the quantity 6x minus 7. All right, so I'm going to FOIL this first part. I have x squared plus 2x minus 3 when you're all said and done. And then I'm going to distribute the negative minus 6x plus 7. And it's all over that denominator, x minus 2 times x minus 1. Simplify the numerator, x squared minus 4x plus 4. All over x minus 2, x minus 1. All right, factor the numerator. Let's see, that would be what? X minus 2, x minus 2? All over x minus 2, x minus 1. Simplify. We can cross out factors here, and that simplifies to x minus 2 over x minus 1 with the restrictions that x can't be 2 and x can't be 1. Okay, so notice your restrictions go along with your least common denominator, that least common multiple. All right, next one. I have x minus 1 over x plus 5 minus x plus 3 over x squared plus 6x plus 5. All right, this first term, well, that stays x plus 5. Here I'm going to factor x squared plus 6x plus 5. The linear factors are x plus 5 and x plus 1. So that least common multiple, well, I've got to deal with each factor, x plus 5 and x plus 1. Well, restrictions. Restrictions are what makes that least common multiple equal to 0. So x can't be negative 5 and x can't be negative 1. All right, there's my restrictions. All right, so let's figure out, let me grab that red color here. Actually, nope, I want the blue because I need to write it as my subtracting, and I have x plus 5, x plus 1, x plus 5, x plus 1. All right, got my denominators. Now I'm going to grab that red color. For that first term, I have the x plus 5. What do I need? I need the x plus 1. So I'm going to take that x minus 1 and multiply by x plus 1. And then out of this second term, I don't need to multiply by anything, so I've got that x plus 3 because I already have that entire denominator. All right, so I'm going to rewrite this all over the same denominator. And that would be x minus 1, x plus 1, those multiplied together, minus the entire quantity of x plus 3. I'm going to FOIL this first part, and that's the difference of squares, so that's going to be x squared minus 1. I'm going to distribute the negative minus x minus 3 all over that denominator. All right, simplifying, I got x squared minus x minus 4 all over x plus 5, x plus 1. So now I've got to look to see, can I factor the numerator? Answer is no. That is simplified. Okay. All right, now there's a little something called complex fractions. And when I say complex, yes, they are complex. It's when you have rational expressions that has at least one fraction in the numerator and the denominator, or there's fractions in both, multiple fractions, fractions with fractions. So we've got to simplify a complex fraction by multiplying the numerator and the denominator by that least common of all the rational expressions. We can also combine the fractions in the numerator and those in the denominator, then multiply by the new numerator by the reciprocal of the new denominator. Well, you know what? Let's just jump right into it and I'll show you what that looks like. Okay, here's our first example. Notice I have fractions within fractions. That's a complex fraction, all right? Looks like the numerator is pretty simple, but the denominator, not so simple. Okay, I tend to just kind of do little side notes. So the top, well, that's as simple as it's going to get. The denominator, well, let me do a little side note. I'll do it in red here. I have 1 over x plus 1 over y. Least common multiple, xy. That means I am multiplying, I'll grab purple, multiplying here by y, and here by y, and this one by x, and here by x. Okay, so when I do that, and I rewrite it all over the same denominator, I get y plus x. All right, now that's as simplified as it's going to get. So let me rewrite that up here. Y plus x divided by xy. Okay. Well, have to admit I go a little old school when I rewrite these. So this is like x divided by y plus x over xy. Well, let's see. That's the same as multiplying by the reciprocal of the second term, xy over y plus x. Okay, now keep in mind this is the x is the same as x over 1. Multiply the top, x times xy is x squared y. Multiply the bottom, 1 times this quantity would be the quantity, so y plus x. And there you go. Okay, now few things we've got to look at for restrictions. We've got several, actually. Let me pick a different color here. Let's go with orange. So for restrictions, just like before, we look at that least common multiple. Okay, so least common multiple is xy. That means x can't be 0, y can't be 0. All right. Now, when we multiply by that reciprocal, I have to look at the denominator. Okay, I've got to look at this denominator right here. So when does y plus x equal 0? Well, you can either say y would equal negative x. So that's a restriction. Y can't equal negative x. That's your 3 restrictions. So you're always going to look at here, your least common multiple, okay? And then you're also going to look at the denominator of when you did the reciprocal, okay? Those are the 2 spots. So with a complex fraction, you have to look in 2 places for restrictions, okay? All right, let's take this next example, and this will be our last example. That's why I wrote the end at the end there, so I knew when we were getting close to done. All right, so here's what I see. I see we've got a numerator, and I see we have a denominator. Okay, let's start with this numerator. I have x minus 2 over x plus 2 over x plus 1. Okay, the least common. That least common multiple will be, let's see, I've got the x, and I have this x plus 1, and that is its own quantity. So x times x plus 1. All right, let me grab the red. That means I have to multiply here by x plus 1 to get that denominator, which means I got to multiply it on the top. And then down here, if that's its own group, then I need to multiply by x. And that will give me my least common. I'm going to go ahead and put it all over that least common denominator. Okay, what do I have? I've got x minus 2 times x plus 1 plus 2x. All right, well, let's see here. Foiling that x minus 2 times x plus 1 is x squared minus x minus 2. And then I have plus 2x all over the denominator. Well, that is x squared plus x minus 2 all over the denominator. Let's see, factor the numerator. That would be x plus 2 times x minus 1 over x times x plus 1. All right, that's the numerator. I'm going to rewrite that up here at the top. X plus 2 times x minus 1 all over x plus 1. All right, now that is divided by, let me erase these equal sign here. And I always try and make this divided by, that fraction bar, a little longer than the numerator fraction and the denominator fraction, just so I can keep it separate. All right, so let's take a look at this denominator. I have 3 over x minus 1 minus 1 over x plus 1. Now keep in mind that x minus 1 is a group, that x plus 1 is a group. All right, what's the least common multiple? Well, let's see here. I've got an x minus 1. And then I have an x plus 1. All right, let me grab that red. Let's see, this first term, that means I'm multiplying here by x plus 1. X plus 1. And then the second term, I'm going to multiply by x minus 1. Top and bottom. All right, so with this, I'm going to rewrite it using that common denominator. So I have 3 times x plus 1 minus 1 times x minus 1. I'm going to distribute 3x plus 3, distribute, minus x plus 1, all over x minus 1, x plus 1. All right, combine like terms. I got a 2x plus 4 over x minus 1, x plus 1. All right, factoring out a 2, I'm going to have 2 times the quantity x plus 2 over x minus 1, x plus 1. All right, I'm going to move that to the top here. I've got 2 times x plus 2 over x minus 1, x plus 1. All right, so let's go ahead and keep working this out. All right, so I am going to just kind of, I'm going to use yellow, bubble in that work, okay? I'm all done with that work. So I have simplified the numerator, I have simplified the denominator, okay? I'm now going to rewrite this. Let me get the blue. I'm going to rewrite it old school. So the numerator divided by the denominator. So just like you see it. Notice I'm not doing too many steps at one time. Okay. I'm going to start my restrictions at this point. You got to look at all of your denominators here. So x plus 1. Well, let's see. X can't be 0. X can't be negative 1. The other denominator, x minus 1 times x plus 1. Let's see. X minus 1. X can't be 1. X minus 1. X can't be negative 1. Already got it. All right. So I'm going to keep going. And I'm going to take the first term times the reciprocal of the second term. All right, so right now, since I did the reciprocal, I've got to look at the denominator of that reciprocal, and are there any additional restrictions? Yeah, you have this x plus 2. That tells me x can't be negative 2. So my restrictions are 0, negative 1, 1, and negative 2. Let me box that in because that's part of our answer. Now let's simplify. Okay, when we multiply, this tells me I'm going to multiply the top. Notice I'm leaving them all in factored form because I want to know if there's any factors on the top that are going to simplify with the denominator. All right, here's what I see. We have an x plus 2 on the top and the bottom. We have an x plus 1 on the top and the bottom. All right, now that looks like it's it. I have x minus 1 times x minus 1 on the numerator. That's x minus 1 quantity squared. On the denominator, I have x times 2, which is the same as 2x. And that is simplified. So we simplified our complex fractions. Basically, you got fractions within fractions. All right. Notice none of these problems that we did today with simplifying rational expressions by adding and subtracting rational expressions. Want to take your time doing it. Make sure you write out all of your steps. Hope this helps.